Our group created a database using Oracle SQL Developer for the Rent-A-Ride company. Our database consists of 4 parent entities named Client, Employee, Bicycle, and Station. The client table is used to store data about clients that want to make use of Rent-A-Ride services. The table contains all the important information about the client, and a primary key is generated using a sequence. The bicycle table is used to store data about all the bicycles that the company owns. It indicates what station the bicycle is, what the condition of the bicycle is, and whether the bicycle is available to be rented out to clients. A primary key is also generated for the table using a sequence. The station table contains data about the different stations that the business uses across Potchefstroom. The table also indicates what employee is responsible for every station, and the location of the station is also saved in the table. The station table also contains data on how many bicycles are available at every station. The final parent entity is the employee table. This table is used to save crucial data about the employees. Their personal details are saved in the table, like their name, surname, cell number, ID number, and email. It is also indicated in the table if the employee has admin rights. A primary key for the employee station is also generated by using a sequence.
For the bike rented table, we have the following attributes. Rent ID as primary key, bicycle ID, client ID, station ID, and employee ID as foreign keys. There is also a normal attribute, date and time. The table is used to see booking details of the rented bikes, like where it was hired and by who. The employee station table is used to store the information about what employee is at what station. It has the following attributes. Employee station ID as primary key and employee ID and station ID as foreign key. The payment table handles all the payment information, like the client ID, rent, transaction date, and the amount paid. It has transaction ID as a primary key and client ID and rent ID as foreign key, with a transaction date and the amount paid as normal attributes. Next, we have the return table that shows us all the bicycles that have been returned safely. It has the following attributes: rent ID as primary key and rent ID as foreign key. We also have an outstanding table that shows us all the outstanding payments with the following attributes: outstanding ID as primary key and rent ID as foreign key.
In this section, we will discuss how populating the database is done and how views and indexes are used to make a more efficient database. Choosing the correct data types are essential in creating a database. These data types are all used for specific functions, and each table can contain different data types to ensure that the correct information can be stored. The data types used in our project include autonumber, varchar, character, number, and timestamp data types. Creating views can be very helpful for retrieving specific and important information. This allows for subsets to be created by combining information from different tables. This makes filtering and managing much more efficient. We make use of 4 views to retrieve information that is important. The first view is used to see all available bicycles and their location at the time of the inquiry. The view admin determines what employees are admin employees. The next view is used to identify stations that do not have available bicycles at the time of inquiry. The last view is used to keep track of individuals who have not returned their bicycles after usage. These views create a much easier way to quickly access valuable information. Indexes are also implemented in the database. This index allows for more efficient inquiries by creating another unique identifier besides the primary key. The payment index keeps track of all the amounts paid for every payment, as these values can be duplicates.
Selections from tables This is to select the relevant data from the table. This is to display the information as it is required by the office staff for administrative purposes. We have multiple selection statements, such as payment, bicycle, employee, outstanding, employee stations, client table, station table, bike rented, admin employees only, bicycles available, no bicycles available, and non-returned clients. These are all relevant to our business model as it is required for us to complete our daily tasks and to ensure that everything runs smoothly. Limitations of rows, columns, and subqueries. This query we have here is to eliminate the client ID field if there is a duplicate in it. This is necessary for the business as bookings are reliant on the client ID field as the identifier. If there is a duplicate, two people can be charged for one's renting of a bike, or it can make an error that won't make the system work at all. This is why it's very important for us to remove these duplicates. Grouping, group by, and having with aggregate functions. The first function we have is grouping stations according to the station ID based on the bicycle amount. This uses the average bicycle amount to display the stations that are mostly popular. These are only applicable to the stations that have more than 5 bicycles at average, and so we can determine a more accurate number of what stations need to be restocked more frequently. The next group by, we have group by client by the sum of the money they have spent. This is so the client can be eligible for a reward system for loyalty points earned by spending more money at our company. To be eligible for this, the client has to spend at least 250 Rand each month. This is also ordered by the sum amount of each client, so we can determine which clients deserves the most loyalty points.
Okay, then we have the sorting query. This is used to retrieve a sorted list of all the stations that have between 0 and 5 bikes available. The business application is to be able to identify stations that needs to be restocked with bikes. Then next we have the sorting of employees. This is used to retrieve a sorted list of all employees sorted by their surnames and names. Then the like and or query. This also has a join in it. This function is used to select the distinct information from the bike table. This has a business application of allowing the customers to only be able to select bikes for booking that is in good or in great condition. The bike must be able, like the variable must be true, and then it must be in good or great condition. It uses information from the bike table and joins it with the bike rented table to be able to determine if the bike is available, and this is accomplished by the join. Then we have the returned statement or returned query. This function is used to select all the data in the table from the return table and has the business application of knowing the total bikes returned. And then lastly, from my side, we again have a select statement that is the count, and the function of this statement is to select the total count in the station table where the bike's amount is greater than 8. This has a business application of knowing the total of bikes in the stations that is greater than 8. This is also applicable when they must be restocked.
This query displays all customers that have currently booked a bike along with the bicycle they have booked. This is useful to keep track of who is currently out on a ride and on which bicycle. This may assist in inventory control and safety measures. For this query, we make use of the trunk function in SQL to determine in which quarter of the year a payment was made. The query functions on the transaction date of the payment table and helps the company to compile their quarterly statements for the financial year. The purpose of this query is determining the average amount paid by a customer to book a bike. This query makes use of the round function to round the answer for a better estimate. The extract date function is used to determine in which year a bike have been rented. This query could prove useful in determining which year has been the most profitable. This query makes use of the current date function in order to determine the number of bicycles that have been rented on the current day. This is helpful as it indicates how many transactions have occurred for that given day. The last query we have is to select a payment transaction for a specific date. For this example, we have selected transactions for the 4th of December 2020. The transactions are then ordered by client ID for convenience.